Now we'll be hearing from Dr. Paul Stackhouse from the NASA Power Project. Paul will be covering Power's 25-year-long journey and the roadmap we've developed for the future of the Power Project. Paul, take it away.
Thank you very much. And it's really, I'm just so thankful for everyone. Make these data products available. We need to, they're used for building modeling, and that's what Drew is trying to show us. So what we'd like to do today now is show you kind of the breadth of what power is. The breadth of what power is, and then show you a bit into our roadmap and to where we've been and where we're going to go. So all right. So we, as been noted, we're celebrating our 25th anniversary, which is quite a long time. But we were been working on retrieving solar irradiance data products tracing back to the late 90s. Started working with the National Renewable Energy Laboratory, who had customers in Africa. And that's where we started to make these sorts of data products available. So as our overview, we are aiming to provide these data products from Earth observations, building around the retrieval of solar irradiance and related parameters, and making them integrated into the decision-making process. And we had these three focus areas: the renewable energy development involving implementation in solar systems, whether detached from buildings or involved in buildings. And then, of course, the building analysis itself and energy efficiency, as Drew just gave us some examples of. And then actually we've formatted data products for the agricultural community because of their need for solar irradiance. So all these have different sorts of needs, and they depend to different degrees on the solar irradiance, but also temperature and humidity and wind, as Drew has actually already introduced to us and mentioned. And these three examples are three users, and actually we have a presentation from the 3M company during this conference, and we're very happy to have that, and we'll have that tomorrow. And these are the sorts of users, the sorts of companies that we've tried to support through supporting specific decision support tools, which we'll describe in the future talks. But to give you a sense of where we've come from over these past 25 years, wanted to give you a sense where we started. We started with a very short data product, very coarse resolution, 280 kilometers, all the way back in the late 1990s. That was the first data product used and delivered for evaluation for solar refrigeration for vaccines in the Africa refugee areas. If you look at this figure that down at the bottom left here, you'll see this orange line, which is the installed solar energy capacity of the world. It's in kilowatts, and this is a non-linear scale. That white line will show you, as we go through the years, how we have increased the users. And the point here is that we've gone through in time as we've worked with different communities, and we've, for instance, adding the sustainable building like ASHRAE, as Drew has already introduced to us. It took us about 5, 6 years, 7 years to get to near 600,000 data requests fulfilled. But then as we worked in time, we started to branch out and work with newer communities, for instance, providing daily average for the agricultural community in formats they can use in crop modeling. And then we developed a near real-time capability with a few days of real time providing global irradiance from observations. And you can see that we've now, by 2012, we've been able to improve all those base data sets and have increased by over fulfilling 6.7 million from the history, 6.7 data requests. But just in the next few years, we started to notice that the user's needs really changed. We used to provide data products in ASCII-based formats and tables for requests. And in the 2015 or so, we started working on and adapting and utilizing agreements that NASA had with Esri and their ArcGIS tools, and incorporated those into our web services and developed the GIS compatible. And you can see we've jumped from nearly 7 million total data requests just to 55 just in that time period from 2012 to 2018 by the time we released that new GIS. Just wanted to say that as we've moved to the modern era, we've now increased by another factor of 5 in the users and eclipsed 255 million data requests fulfilled by adding hourly data, and now being able to serve more users by our cloud-based services. All right, so what we wanted to do today, not provide too much detail, but give a sense of overview of where these input data products are coming from, some of which Drew mentioned. So the surface radiation comes from a couple different sources. There's one project called this surface radiation budget, which really adapts images from the global images from both geosynchronous and low Earth orbiting or polar orbiting satellites. And those estimates of cloud properties, global every 3 hours from 1983 onward. That we use radio transfer and information about those cloud systems and other information about the atmosphere to estimate the solar irradiance. But then in 2000, of course, in our EOS era here at NASA, the Aqua and Terra instrument were launched, and both of those instruments had what we call the Ceres instrument. The Ceres is the Clouds and Earth's Radiant Energy System instruments, and those instruments measure a broadband radiation, and so allow us to use the top of the atmosphere broadband radiation to constrain and provide much more stable measurements than imagers to estimate then the surface based upon that. So we still produce global cloud properties, but we use the Ceres instrument and the Ceres data products, particularly the hourly data products from Ceres to do the long-term time series. And we also use another project within Ceres called FlashFlux to do our low latency products, currently still at the daily level. Now, we'll talk a little bit, but those we are migrating from the Terra and Aqua platforms to NOAA 20, and this is how in Power we're going to be able to handle the Aqua and Terra transitions. The other set of products that Drew mentioned was from atmospheric reanalysis to simulations, and just to provide a brief overview, we work with Goddard's Global Modeling and Assimilation Office, and they have assimilation systems there. And essentially that represents a model that's optimized with surface observations. So the little depiction here in the bottom right provides an overview of the sorts of measurements that are assimilated to optimize the model runs to determine the surface meteorological properties such as temperature, humidity. We also take some estimates of precipitation from these products and other related surface products, parameters, I should say. And so they have a near real-time version, which we use in the FlashFlux, and we provide in through Power. And then after a few months, the MERA 2 is run, and the MERA 2 represents their long-term historical data assimilation run, and those represent the data products in terms of temperature, humidity, and surface meteorology that you can provide through the Power website. We've also recently added the NASA's Global Precipitation Mission, the iMerge data products, the early versions, and those are daily average precipitation fields. And here's an example of it, and it's at 10-kilometer resolution for those. So that provides an overview of the data sets that we have been featuring. And to provide those data sets to the users, we've developed over time what we call an application programming interface. And that essentially gives the user the ability to directly pull and order data through a URL type command. So we've developed a URL command language now conforming to recent standards. And that language underwrites the Power Web capabilities. And so, but using that API, leveraging that API, we've built on top of that this data access viewer, and that'll be demonstrated in the technical talk coming up. But this data access viewer allows the user to interactively order the data products for the locations and parameters that they're interested in, and then actually even learn a bit how to use the API. But we have, of course, numerous tutorials to do that as well. And finally, we've been deploying progressively the geospatial services by our working with the Esri, ArcGIS Imager Feature Services, and those have been featured on the NASA's ArcGIS Online and also on the Esri Living Planet. So, our roadmap aims. Where is power going? Well, we are aiming to continue to improve decisions and learning outcomes in these high value sectors and in these areas of remote renewable energy, sustainable infrastructure, and agroclimatology. And trying to provide these products anywhere in the world and try to assure the high quality as possible. One of the things that Drew is doing, we do take time to compare all our parameters to measurements and Drew is helping us to do that just by looking at these various locations. So data quality is important. So by way of our introducing our roadmap, we wanted to note that there's an increasing visibility and increasing uh, agreements within the U.S. government and within the international community to foster programs to promote uh, uh, cleaner energy development and deployment around the world. And so through a number of these sorts of agreements, we have strived to go ahead and provide data products and support the growth of these various themes, communities. For instance, the renewable energy community has been growing by 15% per year, and that's expected through at least 2030, and sustainable infrastructure and its uses is continuing its annual growth in that range of 16 to 18%, and agroclimatology, continuing demand for data doubling by 2029. So we aim to help satisfy the needs of these communities, and particularly this goal of the net zero greenhouse gas emissions by 2050. And so those sorts of long-term goals require data products at a number of different temporal averages and spatial averages. We need the long time series data, which power features, but also being able to update those data, improve those data, and support understanding of the current climate variability, climate and weather variability for everywhere. So to enhance, so our roadmap now includes 8 different activities. The first 4 are aimed at enhancing our core products and services as they are. So one of those is to enhance our solar meteorological information that we're currently currently featuring. So maybe that is by interacting with different businesses and user communities, we have new parameters that we can identify. Or maybe that is propagating the changes in, in the current key input source data products, making sure that those get propagated out through the website to these user communities. To do this, of course, we'd have to keep improving our hosting environment. So we have a lot of work toward that. You'll hear some more information on that. And then we have some plans that we'll show you here in a moment to improve spatial and temporal resolution. And then, of course, our capabilities to do analytics and services have to scale with that. But also, we want to look long term at expanding the offerings, including adding global climate model projections to help connect the current variability that's observed to future projections of variability under different scenarios. And also, we have the opportunity to work and feature products related to seasonal forecasts. And so we would like to develop that as well. As we've interacted with users, we've heard the needs for more meteorological, hydrological parameters. And so we would like to feature more of those. And of course, we're going to be having new missions, as Emily described, the Earth observation system missions going up. So how can Power incorporate data products from these newer missions? Just briefly, I wanted to just mention that our key data products consistently have plans for their own updates. For instance, GXSRB is working on a half-degree data product that we think should be ready in the end of 2023 or so. And the series team is working on a whole new version called Edition 5. Uh, and um, and so this new edition will add NOAA 20. I mentioned the Aqua and Terra fading out, but Ceres has a plan to process the NOAA 20 measurements and estimate the fluxes and provide continuity and the transitions from Terra Aqua to the NOAA 20 time periods. They will probably also feature a new reanalysis for their air 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 and atmospheric properties, and they've made a number of improvements in their cloud retrievals and radiative flux estimates, and they've also done a lot with ensuring long-term consistency on stability of the data products. So that major addition is coming out probably in the late 2023, 2024 timeframe. And so that will end up, we will end up propagating as those new ones out. We will reprocess and propagate those data products out as part of our Power project. Also, there's going to be some changes to the low latency. Currently, we use Aqua and Terra for our low latency data products, but we're in the process already of migrating to NOAA 20. And also there's going to be a new reanalysis. I mentioned that GSIT, which is the next step reanalysis from the Goddard's GMAO. And so this first step is to take a big step to go to this new satellite, keeping probably using still Aqua for the morning, and but the NOAA 20 for the afternoon. Sorry, skipped ahead there. And then we'll be actually the long-term plan for Flash Flux is to bring in the geo observations as well to support hourly fluxes at the lower time resolution. And then at the bottom here, we have some plans for the GMAO themselves. Not only do they have this new reanalysis, which should be starting in a few months, this is their new real-time reanalysis, which has a number of improvements and updates in their simulation and modeling system, but also they have an intermediary version aimed at 2000 onwards at double the resolution. They're calling 21C, R21C, which actually has some new assimilations, including cloud liquid water, and then Long term, the GMAO has a version to reprocess their historical run. As those products become available, we'll evaluate them and propagate to the user as appropriate. So the bottom line here is that power is not a static data set. We continue to evolve, particularly as satellite systems and analysis data products are available. All right. One of the things that we would like to address is moving to higher resolution products, and we have a plan for that in our roadmap. Currently, we feature long-term coarse resolution data products. So the radiation data products, for instance, are still at the 1 degree resolution, but we know that there's quite a bit of demand for higher resolution data products. So we've developed a plan here to work with some groups here doing higher resolution, medium resolution products to about 20 kilometers, looking at the global satellite cloud products. And so we have some test data products already and are working to provide those data products on power-like ordering systems. And so that's going to be something that we're building toward. And then we're also in the future looking at an effort to look at specific areas for ground station links for particular overpass products. And the idea here is to provide products for just certain locations, certain regions near a ground station link. They would be high resolution and very low latency. So we don't say that we're going to go a higher resolution, low latency globally, but definitely certainly regions. And to attain those sorts of things, we'll be looking for partnerships to build on in the future. All right. Well, uh, we are looking here at some of the roadmap plans for improving our data products in our data services. So one of those is our new DAV. This is a mock-up version of it, and you'll see it demonstrated in the next session. And so we are developing new ways to represent the images and also provide some analytic services and different plots. So, for instance, at the bottom, there's a heat map. And we're going to be um, also providing data products through AWS. Uh, since we're now currently have migrated to the Amazon platforms, and and so we have data products available through the open data program there. And also, we are deploying more and more image services so that utilizing Jupyter notebooks for encouraging the analytic use and access of the data product. All right. Well, one of the things that we really want to add to the power capabilities is to introduce the climate products. And and so we have started a new activity within NASA to work with NASA's own Office of Strategic Infrastructure. And here we're collaborating with the Canadians uh, Screen International, which we'll hear from Greg Lang uh, tomorrow discussing this. It's a key decision support tool that Power supports. And they have already used Screen to model all the buildings on NASA centers, at least over 800 of them. And now we are special processing from the CMIP 6 climate runs and working with a group at NASA that has a downscaled global data product called the NEX project based at JPL. And so we are starting to analyze those data products so that we can understand the differences for various different climate scenarios in a large ensemble of models, looking at over 22 different models. The downscaled products are about 25 kilometers and run out to 2100. And what's different about these NEX available downscaled is that they have multiple different parameters. So not just temperature, but also daily minimum and maximum temperatures, relative humidity, wind speeds, precipitation, and the radiative fluxes. So we'll be able to look at all these parameters and integrate that into the building modeling. And you'll hear more about that, the building modeling through the RETScreen tool tomorrow. And so we've already begun assessing these climate downscale simulations, and this figure here shows the cooling degree days for Langley. Notice that we look at the variability. The variability seems to be captured pretty well here, although there seems to be a low bias relative to the surface measurements. So we're comparing to surface measurements, we're comparing to the model runs, and the various different scenarios here. And we'll be doing this for all the centers. And then as we work on this project, we'll be and assess those, we'll be looking to generalize to the world. And so one of the things is what sort of products would we regenerate? Well, we would talk about generating what Drew talked about, those ASHRAE climate zones, but now not just for our last 30 years, but on into the future to 2100. How do those zones evolve in time? And we'll be able to provide interactive user services so they can visualize that. And then, for instance, this is a figure here that's in one of our image services where we've taken the differences in the zones between an earlier period and a later period. And the red here marks changes in the zones or essentially a nudge toward a warmer climate zone in this instance. And so we'll be able to do that for over the long term for different decades. We also have a number of other parameters that we'll be able to develop, including developing time series for different decades that can be used for building simulations. And then I also want to mention our attempts to use and integrate current and future Earth observation missions into the data streams for the future data products, power products. One of the first priorities is to look at this soil moisture active passive mission, SMAP. And this is just a figure here that's showing global soil moisture. And so this information is very important for electric utilities and other information. And so this would be something that would be incorporated as part of the power's parameters. There's other missions going up. There's the surface water and ocean topography mission, which has surface water information. And then the TEMPO mission, which represent a way for us to do a regional moderate resolution. TEMPO, the feature here is the pollutants and gaseous information. It's available for the North America region, but it's available at the hourly resolution. This has been requested by the buildings folks in ASHRAE in regards to filtration systems, so that they can have information on pollutants and relevant to their areas. And so this would be an example of providing a regional higher resolution tool. We also have the PACE mission planned, and what's interesting, even though PACE is focused on ocean physics, there is a complete global clouds and aerosols and new aerosol instruments going on PACE that are going to be innovative and should improve global aerosol, our understanding of global aerosols, which is important for solar irradiance and solar power. And so we would be interested in working with the PACE teams. And long term, there's a new radiation data set, an instrument being developed, which is planned for launch 2027, which will follow on from NOAA 20. And so those are some long-term missions that we would definitely want to consider. But the most success will be to partner with you. So we want to continue to build partnerships within the various communities that we've already started within the renewable energy, the sustainable buildings, and the agricultural communities to gain more exposure and to learn more about requirements and needs for our challenge to go toward more sustainable and resilient infrastructure and general deployment. We also do want to focus with the private sector, particularly as people are doing long-term planning exercises and might need these climate services. We would certainly like to work with those sorts of partners. And then obviously we do support and continue to support the educational sector and we have had nice relationships with a number of universities. In fact, on October 6th and 7th, we have a workshop at the University of Wisconsin. We'll provide a link for that later, but Power will be participating there. But we're looking at supporting the energy industry with remote sensing data products of all types, not just what Power features, but also other ones as well. So we're very interested in partnering with universities to develop these sorts of capabilities. And then, of course, with the federal sector itself, and some of these that are already in place, and we want to improve those relationships. But even by partnering with the RET Screen team, they already support all the federal buildings in Canada, and so this is a major partnership success that we've had with the RET Screen team, uh, and partnering with the federal sector. So that concludes us for this overview of where we've been and where we're going. And I just want to thank everyone again for getting online. I haven't been able to see the chats yet, so I don't know if there's any questions at this time. Okay, no questions. So we will continue, and I'll ask Madison to jump back on. Thank you.